Hello, all. I'm Witty Bindra. I'm the board member at PanIIT USA, and I'm here to introduce our great speaker for today's webinar, Dr. Chaitali Sengupta. So, just to give you some background of Chaitali, Dr. Sengupta is a co-founder and CEO of Cyrus 360, based in Richardson, Texas. The company is a deployment-specific 5G technology and leader leveraging uh, intelligent automation. Cyrus 360 has been recognized with the Global Mobile GLOMO Award in 2024 Mobile World Congress in Barcelona for its significant digital technological achievements and has received accolades from both the US National Telecommunications and Information Administration and the US Department of Agriculture for its 5G and edge solutions. Before Cyrus 360, Chaitali held key roles at Qualcomm, Reliance Jio, and Seven Networks, and was a founder of SNR Labs. MIT Technology Review has recognized her as a top innovator and an outstanding alumna of Rice University, Houston, where she earned her PhD in electrical engineering. She also holds a BTech from IIT Kharagpur and has authorized and authored 50 patent families. I would like to invite Chaitali to discuss the evolving landscape and challenges in next generation telecommunications, focusing on open machine learning enabled 5G, 6G technologies. She will outline her vision for an automation driven future in 5G/6G access network that foster innovation and meet diverse market needs. So Chaitali, once again, welcome to this PanIIT USA webinar series.
Thank you, Witty. Let me share my screen and we can get started. I hope if you can confirm, Witty, that you are seeing the screen properly on your side.
Yes, I can see the screen. Thank you.
Okay. All right. So, well, thank you very much. And thank you, PanIIT USA, for inviting me to do this presentation. And thank you for everyone who is online attending and listening. I'm looking forward to engaging with you in our Q&A session after the first part, which is going to be more a presentation from me. I'll go through some slides and share my perspective on 5G and 6G, what makes its development challenging, and the current push towards open use case specific machine learning driven solutions. Well, I struggled a bit when deciding what kind of content would appeal to you, given there must be a very, very wide range of background and expertise among our audience today. But I thought, well, let's get started with some background on 5G and 6G and context. And thanks to Witty and the PanIIT USA team for kind of helping shape that content. And then we'll dive a little bit into looking at 5G and 6G from a software implementation perspective. So if you or your teams are software experts, you have experience in the latest software 2.0 techniques, cloud computing, applying machine learning to software development, and perhaps you're considering 5G, 6G as an interesting application, hoping you can find some motivation from this talk. So let's start with where we are with 5G and 6G. So 2023 has been a pretty good year for 5G. And going into 2024, we have seen 5G being ramped up around a large part of the world. There are more than 1.5 billion 5G devices in the market. Interestingly, this ramp of 5G has been worldwide, really, with China, India, US, Japan driving the 5G numbers. The demand for connectivity, of course, as you would imagine, is ever expanding, and that is driving investments in telecom infrastructure. And there are some really big numbers when it comes to the market. The telecom network infrastructure market is expected to cross 100 billion USD in value this year. And the interesting market data in this context of this presentation of implementation and software development is the rapid growth in telco software. You see those numbers from IDC, especially telco cloud software, is really growing leaps and bounds, both in diversity, in volume, and of course, the dollar figures. And what I hope to motivate today, that the problems we need to solve for 5G and 6G from an implementation perspective are primarily software problems. We are, of course, as you would know and been observing as customers, as possibly some of you part of this industry, we are in the middle of the 5G cycle. There has been a roughly 10-year cadence of the wireless Gs, 2G, 3G, 4G, now 5G, and 6G standardization is in the horizon. Before you know it, it's going to be upon us. And so far, this system has worked phenomenally well over the last several decades in bringing together a common communication standard across the globe. I mean, I still find it amazing that I take my AT&T phone, land in India, switch it on, and it just works. And sometimes, it takes, some reflection on all the complexity behind just that thing working, right? And that's really been possible through the standardization process via 3GPP and brought together a very, very complex ecosystem. And this process of standardization, as you can imagine, and as well as the development and deployment of this infrastructure has many, many angles, many facets. There are many challenges, and some of it is technical, some of it is policy, geopolitics, use cases, devices, infrastructure. And often when we think of it in infrastructure, we think about the operational aspect of it handled by wireless operators. But there's also the development aspect of the network equipment, the hardware and software that gets deployed. And I'm hoping that today I'll be able to share some insights on the development angle. And from an engineering perspective, software development perspective, like what kind of problem is it? What kind of workloads are we talking about? If I think about, the 5G radio access network as a cloud workload, what does it look like? How is it different? So how are we doing with 5G today? And rather the question we should be asking is, what is 5G and 6G doing for us and will be doing for us? And what does it imply for infrastructure developers? So 5G started out, if you look at this slide on the left-hand side, it's been targeting three pillars when it comes to use cases. The first, the enhanced mobile broadband, which is really your and my smartphones, our laptops, data devices, streaming applications, and so on. The part that we are most familiar with. But then there are two other pillars here that 5G has set as its goal. One is machine to machine. You can think of it as IoT, super IoT, and it's got a whole range of applications involving sensors, other data collections, and data-driven analytics that are going to be helping these businesses. And then for things like factory automation, for healthcare, remote automation, where reliability is key, low latency, even lower latency than the rest of the other two pillars. And for that, 5G has ultra reliable, low latency communications as part of the standardization. So if you look at the whole gamut of use cases, each one of these you can think of as specific requirements, specific goals in terms of quality of service, power, cost, and so on. And if you look at 6G, it's a nice graphic from Nokia on the right-hand side of the picture. The goal here is to bring together the digital world, the physical world, the human world, and really have things like digital twins at a massive scale, AR, VR, sensing along with communications, all looking at it together. And of course, machine learning driven applications at large scale. So if you take all of these things together, one thing that should be jumping out at us is that each one of them, because they'll have their own requirements and own goals, it's very hard to think about an implementation that is one size fits all. And it also motivates thinking about connectivity and compute at the same time, because that's the only way. What matters to these businesses, to the end users, to these diverse segments, is how we can impact their operations, their sales, their development at a holistic level, whether it's a farm or a factory or a mine, the smart grid, whatever, right? So the question, the interesting challenge is, what can connectivity do, perhaps in conjunction with compute, like edge computing, to achieve those business goals for the customers? And if you really think about that, what does it mean for developers of infrastructure? The focus really needs to be on customization, optimization, and of course, automation. And if you think about these words, these are very, very familiar for software developers. So this is essentially a software challenge, and something that we should be able to handle using automation, because just relying on an ever-growing large team of experts, it's just not feasible. It's just not scalable after a certain point, right? So that's one aspect of it, the use case, the diversity of use case. The next one, this is where a lot of the excitement is, leveraging machine learning driven opportunities. So AI ML is expected to influence every aspect of the network, from the air interface, in this picture showing on the left-hand side, maybe more adaptive, more learned, self-learning kind of techniques in air interface itself, new algorithms, new processes. It will influence the standards. It'll also influence how this equipment is going to be built and how these components will get deployed, whether it's in the tower or in the data center. So I started with this picture. This picture is actually from the ORAN Alliance Next Generation Initiative. And what it was really trying to show is the many, many study and work items in 3GPP and ORAN Alliance that is tackling this problem. And just to give you a feel for the breadth of activity that's going on in telecom, driven by machine learning. And by the way, this is kind of an interesting question. And somebody asked me recently, and actually not just one, we have had this thing come up. If you think about these networks, why can't we just have Gen AI generate the 5G or 6G software and map it to the hardware? And I'm sure that's an interesting question that many of you may be asking. The short answer is it's not quite as straightforward. There are aspects of this problem in telecom where Gen AI applies as we know it today. And it applies mainly today to make sense of the vast amount of data from the system. But there are other problems that require different classes of AI algorithms and techniques. And again, what is the implication for infrastructure developers? We've already talked about customization and optimization, and automation is really agility and flexibility. And we are adding that to our set of requirements of hardware software implementation, because what machine learning really does is gives us options. It makes the system more adaptive to the needs, both in real time as well as from the market. And in order to adapt and leverage those options, we need hardware software implementations that are agile and flexible, things that you can change, pretty easily. So we have talked about the diversity of use cases. We have talked about the impact of AI and ML in telecom. The third aspect I'd like to bring to your attention is sustainability and energy consumption challenges. This is, again, something that concerns and impacts every aspect of the infrastructure. It's not only energy efficiency from a standard perspective. One can argue that 5G is perhaps one of the most efficient standards that we have had, and this picture kind of shows that from a per GB perspective. But at the same time, if you look at the total energy consumption, we are on an ever-increasing curve. And some interesting tidbit, a medium-sized metro network can cost $1 billion in electricity annually. I mean, that's kind of the scale that we are talking about here. And that's because we keep adding new features. There are new opportunities to leverage. We need more coverage, network densification, all of that. And that's where, this energy consumption increase comes from. And of course, optimizing the hardware is one aspect of it. We do want to run networks in more and more power efficient hardware, and there's a lot of work going on in that field. But machine learning actually can play a significant role in being able to leverage power savings opportunities, because you get data-driven insights. You know exactly when you can save, what are the power savings opportunities. So this is one area, which is the energy consumption, where machine learning can play a significant role. But at the end of the day, it is really a hardware software optimization problem. And I believe that is ultimately what's going to solve this energy consumption issue and keep it within limits. So let's take all of this together. What is the infrastructure implementation challenge? So we've talked about the business advantages that we need to provide, because it's, again, 5G is just not about smartphones and streaming media and like data-driven consumer applications, but it's really about a whole bunch of diverse use cases from Industry 4.0, agriculture, transportation, massive digital twins, all of that, and both macrocellular operators as well as private 5G, which is kind of a more recent phenomena where, really depending on the spectrum strategy, we are able to now deploy 5G networks for, specific use cases in specific facilities. So if you take all of these challenges along with machine learning, leveraging machine learning, the sustainability challenges, what is actually happening is this blue curve in the center of this conceptual picture. The picture is conceptual, I don't, it's not like, we've real data to kind of show that. It's really showing the trend here. And the complexity that's being shown by this blue curve is in the hardware software implementation, and which relates to R&D costs, relates to time to market, the time it takes new ideas into market, new innovations to market. And this is really exponentially rising. More and more complex the system becomes. Whereas where we really want to be is the green curve, right? We want to be more and more efficient in implementing these solutions. So the question is, how do we bridge the gap? So what is the challenge from a software perspective is how do we keep up and adapt to the new requirements in the network that 5G and 6G are bringing, new use cases, open systems to allow flexibility, whereas the old challenges are still there. At the end of the day, this is a real-time system. It's got its own unique issues of reliability and performance. And, and that's been true, from 2G, 3G, 4G, all throughout. And, those challenges still remain. So it has got, a mix of both old and new challenges as we are going into 5G and 6G. The opportunity for network software developers, I believe, is applying lessons learned in scaling systems in cloud computing and applying it to telecom. So I don't think we can think of a telecom workload exactly as a data center workload. Many of you might be quite familiar with, cloud computing aspects, data center software, those kind of applications, consumer applications. But it's really worth thinking what is similar, what is different, how can we leverage the lessons learned on that, achieving that massive scale in software and apply it here. And of course, the last aspect, we've talked about the direct and indirect impact of machine learning and Gen AI. Direct in the sense of applying machine learning to the telecom network. Indirect because machine learning workloads will be running on our networks. We will be, that's for sure. I don't think there's any argument about that future here. So here's a brief overview of an end-to-end 5G network. So there's a lot of details in this picture. I took this from the Telecom Infra Project. They have a great website, lots of resources there. But I want to point out a few things. If you think about the smartphone on the left-hand side, say, you're running WhatsApp or TikTok or, whatever your favorite application, and you're talking to the internet. On the other side, you're talking to the WhatsApp or TikTok server, the mobile and the server talking to each other. So from a 5G perspective, what's in between? So some of, the big picture components here, closest to the air interface, closest to the tower, is the radio access network or the RAN. So some of the RAN processing happens in the cell sites itself. As you're, driving down the freeway, you will be seeing these towers, you'll be seeing, all the equipment either at the base or, somewhere hanging in the tower. That's really the radio unit. And that's the processing that's happening in the cell site. Some of the processing happens in, what's called the distributed unit, to use terminology from the O-RAN Alliance, and that would happen in the aggregation point or edge cloud. There is some limitation how far from the cell site that can happen, right? So it's a very, very distributed system. And then the rest of the processing happens in the telco data center, the RAN centralized unit or the mobile core, which today is pretty much all virtualized. And of course, it could be the telco data center. It could also be, something that the telcos are running in collaboration with one of the hyperscalers. Right? The physical location of each of these components I just mentioned varies based on the deployment scenario and the network topology. So like if you have an enterprise private 5G, this could be more consolidated. A lot of these components that you see here would be co-located in one place. In a macro cellular network, it would look more like, this picture. So that's kind of part of the complexity. You write your software, you have your stack, your layer 1, your layer 2, 3, and your core, all of that, but then how they're deployed and how distributed or consolidated it is, and that impacts on how they map to hardware, how the data center processing is optimized as opposed to what's possibly in the edge cloud or the radio unit. These become additional implementation challenges. So then the other aspect, which is the various parts of the ecosystem. To put the system that we just saw in the previous slide together, it really takes a village. It's got contributions from developing and deploying the networks and the services from a very large number of players. And this picture is nowhere complete, not exhaustive. There are, in fact, it's missing some buckets. I just use this as an illustration. There are independent software vendors, system integrators that are playing an increasing role in the ecosystem today. But it just gives an idea of the complexity of the ecosystem itself. The silicon vendors providing the hardware platforms, both general purpose and special purpose accelerators, the software vendors and the equipment manufacturers responsible for, the hardware software integrated systems. And then, of course, going across all of these layers are the standardization and industry bodies. The standards are the ones that enable a multi-vendor ecosystem that you see in the picture, both from a development and deployment perspective of a very, very complex system. So the question is, how do we keep the benefits of this approach that's been working so well through the Gs, but also make it more agile and more flexible, and more, plug and play for the multiple vendors that are, building the system and deploying the system. So what does this look like from a design and development perspective? So traditionally, the network equipment has been implemented using embedded systems approach, DSPs, ASICs, FPGAs. I've spent time in Texas Instruments, during time of 3G. And I really saw the transition going from embedded systems to something that looks more software driven, more programmable. But when we were in the era of doing this using the embedded systems approach, we were able to look at every possible scenario. And because the diversity of requirements were limited, we were really doing voice and data, two kinds of application. So we could really think through every possible scenario, as human experts, Heisenberg bugs, which are hard to find bugs that show up in the field. They never show up in the lab. In fact, one of my mentors shares this story that, no matter how much you test, you go out in the field, there'll always be, a bug or a crash that never happens in the lab. So no matter how big your testing, infrastructure is, there's always something that happens. So the question is, how do you defend against that? And the way we defended against this when we were building embedded systems was really spending hundreds of expert engineering hours to kind of think through all the problem. But 5G has actually, is making a change to that. It's really becoming untenable. And that's because it's brought in a dramatically complex application space with very, very specialized needs, which is continuously evolving. And so we really need to start thinking of building the systems in a different way, applying more CI/CD type approach. And these approaches are prevalent in the cloud computing space. Question is, how do we apply here? The complexity is, as I said, the complexity of this application space and the requirements are making the embedded systems methodology just difficult to support. It's just not going to work. So today we are in the era of virtualization and cloudification. You would have heard of, if you're familiar with this, CRAN and VRAN and NFVs, network function virtualization, that's been already working very well in the mobile core space. And that's, and high level of programmability, multi-vendor components, coming from different vendors that still need to be seamlessly integrated by using standard interfaces. And that's really the vision of movements like the Open RAN movement. And the picture here on the right-hand side tells a very interesting story. And, you'll hear me talk about RAN. And that's not only because, that's a subject close to my heart, but that's actually the most complex part of the system. What this picture shows is it's the one that consumes the most energy. It is where most of the infrastructure cost goes in, and it's also where most of the R&D effort goes in. So one of the comparisons I'd like to make here is with the machine learning space. And you can see, we are all familiar with the explosive speed of progress in that field. And I would argue that that's been possible because of disaggregation and abstraction. The kind of software innovation that has happened in the machine learning space with, say, frameworks like PyTorch and TensorFlow, and the development methodology where a developer can write a machine learning application and not worry about how the neural network is going to work on a GPU or a TPU or a CPU, right? There is a software infrastructure that takes care of it. And so it's possible to get that kind of multi-vendor software development and integration efficiency. And actually just, kind of close to home, this is the challenge we have given ourselves at my company, Cirrus 360. I'll share a little bit about that later. And I am talking here specifically about the RAN. The mobile core has already made so much more headway in terms of being virtualized and being either in the telco cloud or in partnership with cloud hyperscalers. But the RAN is not like most other cloud workloads. So if you're like maybe thinking, okay, great, let me just do one of two things. Let me just treat this as any other cloud workload. Let's just apply kind of interesting, generative AI, machine learning techniques to do this. But let's talk a little bit about why is 5G not just another cloud workload, especially the radio access network. So the performance and capacity requirements really necessitate the use of hardware acceleration. And you might say, yes, that's also true for machine learning, and you're right. It's just that it's not only requiring hardware acceleration, it's complex hardware acceleration, it's a diversity of hardware acceleration. And you want to leave it like that because that's where innovation can happen. And there are multiple approaches to it. In fact, in the ORAN context, there are these accelerations called inline and look-aside. There's like a whole diversity of hardware acceleration, and we need to be able to leverage that within that cloud framework. And coupled with that is software running on general purpose processors, mostly x86, possibly ARM servers. But interestingly, these are kind of processors and kind of hardware platforms that are designed for high performance, opportunistic behavior, and may or may not be suitable for real time. And that's why you need innovative software design to make these general purpose processors work well for a real-time system, because what we're talking about for 5G and 6G are real-time system. And there has been a tremendous amount of work that has been done in the space by companies like Intel and other ecosystem players. Predictability of execution, even in apparent dynamic scenario, absolutely key here. And it's very important for this workload. And the reason you need that is to combat the Heisenbergs that we're talking about. You really don't want to see an execution condition like a memory overstepping or a race condition that you only see in the field. You don't, there's no way to catch it in the lab. You really want to avoid that because, that's the kind of thing that can lead to catastrophic crashes. We want to know about it upfront and in design time and be able to kind of, defend against it. And lastly, on this side, security. And when I say security in this context, I'm not just talking about the air interface, like man-in-the-middle attacks or denial of service. We are talking about security of the hardware software implementation itself. So on the right-hand side is a very simplified view of a RAN distributed unit, say deployed in an edge cloud. It's got, all the usual ingredients you can think of in a cloud deployment, the hardware platform, the CAS-PAS platform, and the pods deployed on top of that. But at the same time, this needs specialization of hardware, where it is absolutely needed in conjunction with general purpose hardware. And so there is one hand movement towards software on commercial off-the-shelf hardware, but at the same time, there are certain functional blocks where you need specialized hardware. And all of that needs to work, seamlessly together. So actually, this hardware software design problem is, to computer scientists in the audience, it's actually an NP-complete problem. So from a scheduling perspective, and the more requirements you add, exponentially becomes more difficult to handle, especially manually. So it becomes almost impossible to manually find efficient solutions that will meet real-time requirements. And these are like tight real-time requirements. Sometimes, you can qualify what kind of real-time requirements is firm real-time requirements, but it's quite tight. It's in the range of sub-milliseconds if you go down to each function blocks into the microsecond range. So if you continue to do this manually, it's such a complex problem that it leads to long design cycles, hard to find bugs, and which really leads to vendor lock-in and lost opportunities, right? So once you put something together, you don't want to touch it, right? You definitely don't want anybody else to touch it. So one question you could be asking is, can AI ML help in automating the design process? And I know, this is a question that we get often. It's true, automation is going to be key, but the question is what kind of automation? We don't think, at least, it's not obviously solvable by Gen AI or even deep learning. And for one thing, it's hard to find training data for a problem like this. There is risk of hallucinations. It is a high reliability system, so there is really little room for unknown errors in the field, which is part of the learning process. But at the same time, we know a lot about the system. We know exactly what the 5G protocol is. We know what kind of deployment. We know what kind of hardware. The goals are very precise. It's complex, but it's very precise. Though it is impossible for a human being, like a human system engineer, to hold all the data in the head and make truly informed decisions when it comes to design, it is possible for a machine or an AI to formally define and process using the latest developments in scheduling and optimization theory and come up with optimal solutions that can be hallucination-free and explainable. So actually in Cirrus 360, we focus on this problem. And what we find is an area that is very, very rich in opportunities for innovation. And this is what we believe is going to ultimately close that gap, that complexity gap, that gap in terms of the time it takes for new ideas to get into the market. So much progress have been made in automation of the operations part of the DevOps cycle for 5G, for the RAN. The use of cloud native technologies, RAN intelligent controller, for those of you who are familiar with the excellent work being done in the ORAN Alliance. That's really automating the deployment and operations and really kind of increasing the velocity on the ops side. And this includes applications of machine learning, applications of Gen AI, but the dev side is the one that is still interesting, and that's where the automation is needed to meet the design goals we outlined earlier. And 6G is going to make this more interesting. The air interface may be machine learning driven, and it might be evolving. It may not be static. The implementation may need to automatically adjust the air interface based on training algorithms. It will need to automatically optimize due to a wide variety of deployments and user applications. And also, interestingly, IP contributions from large and small companies. Traditionally, it's been very difficult in the space for small companies to play a role just because of the nature of the systems. And we really, to really take this infrastructure to the next generation and to really, make this sing and dance. Really, we need to be able to get small companies to contribute. So the software implementation of the 6G stack, which is a firm real-time system on existing hardware in the field, must definitely be automated. And as I said, how are we going to automate it, and how are we going to implement the systems and really harness machine learning is going to be the interesting one. So the open challenge here for infrastructure developers, that this is essentially a software problem. How should we design and construct 5G and 6G systems so that one can reliably and efficiently add or make changes to the existing multi-vendor, the existing real-time system without breaking something that already works in the field? So today, what happens is these systems take a long time to build. And once you build it, it's like, don't touch it. It's definitely cannot allow someone else to, add to it. So how do we really change that? Because we know it doesn't have to be like that. And one of the hints here, how about an IP protected open framework? As I mentioned earlier, this methodology has worked very well in the machine learning space. So what I'm saying is not totally out of the world here. The concept of a framework supported by abstraction and automation has been so successful already in machine learning. And that allows integration of innovations in silicon, in software, and algorithms So, perhaps we can follow that example and create similar frameworks for multi-vendor hardware, software abstraction and integration of, the various components, for example, in Open RAN, the radio unit, the distributed unit, and centralized unit without a huge R&D cost, and maximize portability of algorithms across hardware. And someone might have a new idea of doing, say, an FEC algorithm or a massive MIMO algorithm or an optimization to reduce TCO. And we want to be able to really use a framework to integrate all of that. So I would like to wrap up with this last slide, a little bit about my company, Cirrus 360, and what we are doing to handle or to address this problem, this issue of AI-driven automation of hardware, software, as well as software integration is one of the problems we are solving. We have a specific approach to this problem using what we call RDSL, or a RAN domain-specific language driving intelligent automation. So DSLs, or domain-specific languages and architectures, have been motivated, by an excellent, if you get a chance, the Turing Award lecture by Hennessy and Patterson really motivates this kind of a design technique. The idea of RDSL is to be very precise and formal about specifying the 5G and 6G system we want to build. Because once we have that kind of precise and formal description, then we can tell a machine, we can tell an AI that what is it that we want to build. So this technology was actually awarded, as Witty mentioned earlier, a GLOMA Award in Mobile World Congress in Barcelona earlier this year. And today we are using it to generate 5G edge solutions that are tailored for specific business use cases. And we have worked with partners to show how this automation works and what kind of advantages that you can get in some of the KPIs like, power or latency. So following this, I hope the slides, we can make it available to you. I do have a slide on resources. Hopefully, you'll be able to, use this and see what might interest you, whether it's on the RAN side or the core side or purely, the software infrastructure. There is like a whole, slew of resources out there to get started or, to get deep into. So again, my thanks to PanIIT USA, and I wanted to share a couple of initiatives that you'll find interesting, the future tech expert portals kind of, and maybe Witty, you can, add to what's already in the slide, some of these initiatives, and people might have some questions. So let me turn over to Witty now, and I will be back to answer questions. And, hopefully you can put some of your questions in the Q&A link.
Yeah, no, Chaitali, thank you very much for the seminar. It was great. It was a great learning for me. And I hope the audience have enjoyed your talk. That was very enlightening, I should say. So we have got some interesting questions, and I'll ask the audience, if you have any specific questions, please use the Q&A window and put your questions there. And I have got some nice questions I'll be asking Chaitali. Before I go that route, let me tell you about this PanIIT USA initiative. So basically, there are two initiatives we are working on, and these are the outcome of the conference which happened in Washington, D.C. earlier this year. The first one is the Future Tech Expert Portal, which the Department of Telecommunication, Government of India has asked us to develop to help them with some subject matter experts in all these 16 areas we can see on the slide. So any one of you interested to participate with the Government of India on any of these topics, let us know. We'll be more than happy to connect you to the right people there, because they have a lot of projects going on in India, and they're looking for experts to advise them. And this is all a pro bono work, which will be done through the PanIIT USA ecosystem. The second initiative is ISET initiative. And as you can see on the screen, there are 6 initial domain of India-US ISET partnership, which was signed almost 12 to 18 months ago now in the US. And again, I'll request anybody of you who think you can add value to any of the 6 initiatives, I'll be more than happy to connect you to the right people who are working on this initiative globally. And again, we need people, we need subject matter expert in these areas, who can work with the Government of India to make the difference. So I think these are the very great initiatives. You can connect the PanIIT USA, Swati, Chaitali, myself offline, and we can give you more details on that. So let me go over to the questions now. That's the first question, Chaitali, for you is, what role can geospatial data play in optimizing 5G, 6G network performance? And how can machine learning be applied to analyze this data for more efficient network planning and management?
Yep. Thank you for the question. It's very timely, actually. One of the things that I'd like to bring your attention to in the context of that question, again, the work being done in ORAN Alliance, so 3GPP is the standardization body, and ORAN Alliance, the Open RAN initiative. And they have actually really kind of taken a look at the architecture of the network with this kind of question in mind. How do we harness data-driven insights? It can come cross-domain from somewhere else. And what has happened is there are some of these new components added to the architecture itself. The one that comes to mind first, because there's a lot of excitement around it, is the RAN intelligent controller. It's actually, in a way, it gives you, as one of a friend of mine described it gives you a real estate to land on. If you have ideas along what you just described in this question, you can run it, write it as an app. There are standard ways to integrate that app, the RIC, it's called the RIC, the RAN Intelligent Controller. And, you can then harness, that cross-domain machine learning driven intelligence and then drive it, through those standard interface to control the rest of the system.
Excellent. Oh, thank you, Chaitali. I have got one question from my side, and then I will go through a couple of more questions which are on the chat. I can see the Q&A box there. With 6G promising terabit speeds and near instantaneous latency, how will 6G network create new applications and user experiences that we can't even conceive of yet?
That's a question very, very, very close to my heart. And, I'm a huge believer in thinking from the use case backwards. And I do believe that from our community, from the development, from the engineering community, we really need to think about what kind of problems we'll be able to solve, like in terms of what can 6G do for the application space instead of the other way around. So instead of thinking, okay, 6G can do all these things, higher data rates and lower latency, let's think where this can apply. For example, massive digital twins for factory automation, one example, right? Where, you really can apply this kind of, simulation, emulation, digital twin technology to make your operations more efficient, your design more efficient, more learning. And those kind of, working backwards from there, that's where I think, 5G advanced and 6G will really shine, where we say, okay, this is kind of an operational or a development problem in a different area that really requires that higher data rates and lower latency, instead of just thinking of it as a data service for faster data and lower latency, but really thinking backwards from the problem is, I think, where we need to go.
Excellent, great. The next question is from Vasudev Delwar. He's asking where to start the development of AI for 5G/6G.
Okay. So, maybe you're asking that question in, it could be one or two. If you're asking as a developer, right? So you have a developer, who has a background in machine learning, what can happen here? Again, I would, draw your attention to, first of all, there is a ton of research that's happening, just, looking at Google Scholar and so on. And I can maybe add some resources over here in terms of really understanding what's happening in the space. But then in terms of development, I would again bring your attention to entities like the ORAN RAN Intelligent Controller, which really gives you a space to actually develop an app and deploy it, take it to an operator, and kind of add value from that perspective, right? So those kind of resources is where you could start by looking at not only 3GPP, but also, like ORAN Alliance and also Linux Foundation, all these industry bodies, have, very good guidance and also reference material on where you can get started.
Excellent. Thank you. Quickly, I have a question from Anand Gupta, and he would like to connect with you offline. And Anand, I will let Swati give you that information to connect with Chaitali. But he's asking is, how can I learn more about your RDSL approach?
Okay, yeah, contacting us is probably the best thing to do. We do have a white paper. In fact, once you get access to the slide, that one slide where I describe what we do and we say RDSL, there is actually a link to a white paper. The link is called white paper. It's a paper that we have done jointly with Vodafone and Intel. It's available also on the Vodafone website. So, that white paper would be a good place to start. And then, of course, please feel free to contact us.
Excellent. There one more question. There's a person from India, Mr. Vindatam. He's in Hyderabad and he would like to participate in the initiatives. So definitely we will give you the information. I think I'll ask Swati to send it to you and you can connect with us on that. Again, next one was, how can we download the slides and the video? Yeah, we will give you the link to download all the slides. So Chaitali, other one is, you talked about developing use case specific 5G networks. So compared to traditional implementations, are there any particular challenges or consideration when deploying and operating open use case specific 5G networks?
Yeah, of course. I mean, there is the development side and then there's the ops side. Like, we've already kind of seen that. When we're thinking about operations, the interesting thing about use case specific is, first of all, how do I capture use cases to begin with? And how do I capture intent? And then automation becomes a big part of it because you're going to be doing this, market segment specific or use case specific, it's very hard to, have an army of engineers serving, every single segment. It is going to be important to automate that deployment from an operations perspective.
Yeah. The next question is, what opportunities do you envision for startups or smaller companies in developing solutions for open use case specific 5G applications?
It's great. Again, some of the questions that have already been asked around machine learning, because there is just so much interest in machine learning and Gen AI. So for smaller companies, and that's the other thing, I think the industry right now, especially, the ORAN Alliance, are actually doing a lot in terms of disaggregating the system and kind of evolving the architecture in a way that startups and smaller companies can participate. And again, the RAN Intelligent Controller is a good example that comes to mind. So, developing, solutions that is, machine learning driven, innovative solutions is not just about, taking the protocol and implementing it, but thinking really, how you can innovate both from a hardware and software perspective.
Yeah. Okay. So now this is that's a very interesting question. So what one of the audience asking is, how do you see collaboration between industries, academia, and government driving innovation in open use case specific 5G?
So it's kind of interesting, and you see what's happening, in the USA with, the different funding opportunities, for example, from NTIA, which, my company is one of the recipients there. It really kind of, does two things. One is kind of the innovation angle. It's really kind of, jumpstarts that using government funding, and it can also create a pull from various different sectors. Like, for example, we work on a project with the US Department of Agriculture, right? So we wouldn't have, when we are thinking about technology, sometimes it's hard to really connect to, that end user and that end market segment. And I think, government funding kind of spanning specific sectors and this kind of technology can really create that pull. When it comes to academia, I think it's really about innovations and, research, both not only on kind of, algorithms and signal processing and machine learning, but also in terms of innovations in hardware and software, right? How do we, some of the problems that I described earlier, how do you build the systems, differently? As well as if you think about, and of course, industry, we always, it's like how do you solve a problem? How do you build a product that can solve somebody's problem? And you can, there is the business development, the sales angle of it. And I would actually add to that. You mentioned industry, academia, and government. I would add to that industry bodies, because they play, an important role beyond standardization. It really provides a way, like, bodies like Telecom Infra Project and the Linux Foundation, they really provide a place for collaboration and collaboration of all these entities. So I think, it really, each one of these entities have a role to play. And then there is, the collaboration aspect of it.
Great. So basically, Chaitali, you are based out of US. So when you are addressing industries, academia, government, you are keeping in mind about both the country, like especially India and the US, or that different things happen in different countries?
Yeah, I think there is, there is both. There are always problems that are geography specific, because each market has their own unique requirements, own unique market dynamics. So that's always there. But at the same time, there is technology that goes across that, so when we develop, we don't particularly think about that, this technology is applicable only in the US. We really want this to be something that is globally applicable, that, there are folks that we can collaborate with around the world. But at the same time, when you think about use cases, there are use cases, and that's where things become very interesting, right? That there are use cases that are specific possibly to India. There are, and one of, like, I'll share an example here. We do work, and this is, the work we've been doing, with the USDA funding, working with small and medium businesses, locally here, and if you go, we work closely with them. You walk into one of these businesses, they're still using, clipboards and pens to record what's happening in their processes. And it's not because, they don't have exposure to the technology. It's just that the technology is not geared towards those kind of businesses. And I'm sure that's as much true for, small, medium businesses in India, where it's the technology is there. They don't have IT departments, they don't have consultants to come and tell them how to use it. So we really need to figure out how we automate things, how we make the technology in a way that is consumable by a wide range of markets and wide range of use cases.
Right, right. So just what do you think? What is the time frame for 6G standardization?
Yeah.
What are the anticipated key technological advancements that 6G network will bring compared to 5G?
So if you think about, as I mentioned, like, each of the Gs have been roughly a 10-year cadence. So right now we are starting to think about 6G from a standardization perspective, or, the industry is, things are getting just initiated. So the standardization, I think, is slated for somewhere between, 2025, 2030. And I think commercial release, we probably will start seeing pilots around 2027, 28, and commercial around 20. Again, this can be, anybody's guess. This is from, what I've been reading, what I've been following. This is kind of the timeline that I'm looking at. And it'll also depend on what 6G finally shapes up to be. And there's a lot of debate around that. It's not just a continuum. Hopefully 6G will actually allow some disruption in how the systems are built, because there is a lot of good things that have come out of this kind of a standardization. But, as we discussed specifically already in this presentation, there is actually a need to be more agile, more flexible. And how does the standardization, kind of incorporate all of that? So it's not only, higher data rates, like you mentioned, lower latency, but hopefully it'll bring in a new way of building these systems. And of course, machine learning is going to be, if you look at both 3GPP and Oral Alliance, there are just so many work items on machine learning. So clearly, 6G will have a lot to say about how to use machine learning and how to enable the use of machine learning. It's not about just applying machine learning, but enable the use in ways that the standards won't be able to, it's not like a static thing, that's something that can evolve over time.
Right. I think the final question here says, what open source initiatives or projects exist in the realm of 5G,
Mm.
and how do they contribute to innovation and collaboration?
So that's very interesting question. So I mean, of course, there are many kind of contributions or initiatives from an open source perspective when it comes to 5G and 6G. There is, if you think about the radio access network, there is open source initiatives like the open air interface, the SRS RAN, where you can go in and start and they have implementations of the radio access network stack. There is also resources, open source, some of it open source, and some of it kind of more development environments available from Linux Foundation and ORAN Alliance. So there is kind of range of it. In the resources slide that I have, I do list out some of those, and hopefully the audience here will find that interesting.
Excellent. So, Chaitali, that's all from our side. Do you want, like, any question which we have not asked you, which you want to address, or anything we are missing out on, or anything you want to tell the audience?
I think this has been a very engaging conversations, and thanks for the opportunity. I would encourage folks to reach out to me, to you, to the organization on how they can get involved in some of these initiatives, and also kind of get more interested, as I said, like there are software experts who are looking and thinking about 6G or 5G as an interesting application. People who are not today working on 5G, 6G, would love to hear from them.
Excellent. That's fantastic. So, no, it was an absolute pleasure to listen to Dr. Chaitali Sengupta. So, Chaitali, on behalf of PanIIT USA, I would like to thank you for sharing your knowledge. So, I also want to thank PanIIT USA, volunteers engaged with different initiatives. Special thanks to Swati Deshpande. She is our executive director, and Ravi Sharma. He is our chapter reps. So we have over 20 chapters in the country, and he manages all the chapter activities in PanIIT USA. And their extended team working on these PanIIT USA webinar series, in addition to their full-time jobs and family commitments. So that's shout out to these guys doing a fantastic job. So once again, it was a pleasure having you with us today, Chaitali. And I hope you will return with the next level of tech webinar for our global audience.
Happy to do that. Yeah. Thank you so much. Thank you.
Thank you once again. Thank you.
Bye.